So today, I'll assume that you don't know anything about any programming languages. I just treat you guys as a beginner, and I'll just show you something very basic. Some of you may know more, but let's just pretend that this is our first day to learn anything like this. Okay? So if you're ready, we'll go over the whole thing today. So one thing I like to say is how to get it. Like in CS and Stata, we kind of have some idea. We have to buy the license. In R, it's kind of different. Okay? It's free. It's online. You can just download it anytime and many times, whatever times you want. So how do you find it? So can you open a web browser? Any web browser? So this is my favorite way. I just Google it. So open Google like this and type. You can type R or CRAN, CRAN. Okay. So this is an official website for R. So can you click it? So did you find it? Okay. In the lab, in the computer, we already have R installed. So you don't have to install anything right this moment. But we still like to go over this because I want you to install R in every computer you have in your home. It makes your life much easier, okay? So this is how you install R. So there are 3 links. Download R for Linux. So if you use a Linux, you can click this. The second for the Mac, and third for Windows, okay? So if you have a Mac, you click this. And then you can save this link and you go from there. Basically click it twice. That's all you have to do. What about Windows? So you click Windows and then you click Base and then you click this, and again you're going to see a link. Click it twice. Okay? Then you're going to have R in your computer. So what do you think? Can you do it? Okay, so it's more like an unofficial assignment today. Install R at home. Try to do that. Okay? So you can just insert it everywhere you want. And for now, let's just click this, okay? Oh, I forgot to say a few things about the website. So let's go back to the website again. It has a lot of useful information. One thing I like to show you today is this. Can you click this? Yeah, anyone? So in the first day, I asked my students to buy at least 1 R book, which is typically very cheap. But if you really, really don't want to do that, you don't have to actually, because you have a book right here. An Introduction to R is an R book, very short book for the beginner. So if you want to, you can just use the web page, or you can download it in PDF or EPUB, depending on what you want. So there's some resources available, okay? And the other things are more advanced users. So that's one thing. And of course you can use FNQ. It's not going to be very useful right now. Another thing I like to show you is packages. So the packages means a collection of R functions, special R functions. So the thing is that once you have enough experience and if you know the things well, then you can make your own function and you can make your own package. Okay? Suppose that you have 10 very useful R functions for certain things in data analysis, and you can make a package and you can upload it there with this website. And then other people can download it, install it in their R, and they can use it. The function you just created. Okay, so that's the idea. It's more like a openware for everybody basically there are thousands of functions packages out there. And I think that for almost anything you can ever think about, for the data analysis, numerical analysis, you can find the right functions inside of this page. Okay? So that's again very useful. And another thing I like to say is this. In the first page of the lecture note, it says references, right? So the first one, an introduction to R, is this manual that I just showed you. So this is very useful. The second and third books are kind of textbook for the freshmen at the college. So in the first day I show them. So these are some examples of very good books to buy. So if you want, you can buy them. Now suppose that you have more experience in programming. You know more. Suppose that you used to use MATLAB or something like that. So what you can do, you can get something more advanced. Okay? This is just one example. But you can go to the website that I pointed out there, and there are some documents, and there's some books available, and they are free. So maybe you can get those books and start to read them. Okay? If you're more advanced. So let's go back to R. So what is R? It can be many things, many different people. And I think that, one thing that R can do really well is that, you can basically use it as a calculator, really fancy calculator. So this is what I mean. So suppose that you wanna know what is 2.2 plus 10. You produce the answer. So can you type it? What is 2 times 11? So I produce the answer. So type it. I like to say this a lot. So you have to learn programming by your fingers, not your eyes. Okay? So this is a much better way to learn things. So whenever I do something, please type it in the computer. So basically, it can do the calculations for you. 2 divided by 6. So type it and press enter. That's how you find out the answer. So it's a calculator. It has a lot of functions in it. So exponential of 1. Do you know the answer? 2.7. What is exponential of nothing? It's 1, right? It's log of 1. So it has exponential function. It has log function. What is the sine of 1.2? You type it and you press enter. So what is sine of pi? So how do you find it? Sine of pi is actually 0, right? This is a very small number. It means 0. So you have 1.2, but before this 1, you have 16 zeros. So it's like 0.00, 16 of them, and the number starts. So it's a very small number. The computer, somehow, because of the rounding error, cannot express 0 very straightforwardly. So cosine of pi divided by 2. So it's a very useful calculator. And you can use parentheses if you want to. So the answer of 2 plus 3 times 4, without any parentheses, maybe 14, right? Now if you want to change the order, then you can use parentheses, which is very useful sometimes. Finish with a different answer. You can use more than one parenthesis, like 1 minus 3 divided by 3 plus log of 10. Okay? So you can use it as a calculator. Now, let me try log of 10. So 2.3. So it reminds us that the logarithm has a base, right? You can have a logarithm with base 2, 3, or this natural number, e, or 10, right? So log of 10 is equal to 2.3 means that the base of this logarithm is not equal to 10, right? If the base is 10, the answer should be 1. So your question is, how am I going to change it? How do I know that I can change something in the functions in R to get what I want? So that's what I like to discuss a little bit. So there's a help session available. So if you like to know more about the logarithm, you type help, parentheses, and log, the name of the function you like to know. So basically it has a help page, and you start to read it, right? And we find our answer right here. So it says log of x, x is a number, and you have comma, and then you can specify your base. You can tell that I like to use this as a base, right? The default is the natural number e. If you want to change, you can change it. Let's do it. So log of 10, comma, base is equal to 10. We have a different number. Log of 4, and base is equal to 2. What's the answer? 2. So the idea is that if you don't know something, you can ask help. Okay? Just type help, parentheses, and the function. Or you can simply type this, the question mark. It's equal to help. You get the same thing. Okay? So that's how you learn. That's how you teach yourself about these small things about R. So use this a lot. So you can use R as a calculator, but R can be many other things. So one thing that is very useful these days is to create or generate a random number. So suppose that you like to generate a random number you cannot predict from a normal random variable. So how do you do that? So the function is R So I just generate one random number from a normal random variable. So can I generate more? Of course I can. I can generate a lot. Now, what does it mean? This R means generate. Generate a random number. That's the meaning of this R. NORM means a normal random variable. So generate a random number from a normal random variable, normal distribution. How many? I like to have 10 of them. Okay? So how do you use it? Suppose you can generate a lot of random variables from a normal distribution. How are you going to use it? So one thing you can use is, for example, so this is just very easy example, very obvious example. What is the mean of the standard normal random variable? The answer is very obvious, right? What is the mean? It's the center of the standard normal random variable. It's 0, right? The center. So it's more like just a true statement. Can you prove it? Can you validate this? I mean, so this is kind of funny idea, but empirically you can validate this by generate a lot of random numbers from the standard normal random variables, and then check whether the mean is actually equal to, or at least very close to 0, right? So can you imagine you can do that? So how do you do that? So basically, I just generate 10 numbers from the normal random variable, the standard normal random variable, and I can sum them up. So there are easier ways, harder ways. But easy way is use another parenthesis and say this, type this. So what I just did is the function within generate 10 random variable from the standard normal random variables, the standard normal distribution, and I calculate the mean of those 10 numbers. Right? It's not 0, but it is close. So how to make it even closer to what I want? Generate a lot more numbers. Right? How about 100? Oh, it didn't work. Okay, increase it more. 1,000. Okay, we are closer. How about 10,000? Even closer. How about 1,000,000? So basically, I just generate 1,000,000 random variables from the normal distribution and calculate mean. That's very close to 0. So it's not proving anything, but at least you have some idea what you're going to get from this exercise. So the mean was very obvious. What is not that obvious? How about standard deviation? What is the standard deviation of the standard normal random variable? It's 1, right? So let's check it. Let's prove it. So instead of mean, I like to calculate the standard deviation. It's not equal to 1. It's very close, right? So can I get the same number if I just generate 10 numbers? It's not bad, right? So again, standard deviation is very obvious. But what about the median? What's the median of the standard normal random variable? So it's 0, right? So it's not interesting. What about 90th percentile? Do you know the 90th percentile of the standard normal random variable? That's harder, right? So let's try it. Let me be modest, 10,000. The percentile can be calculated by this function quantile. So I said 90th percentile, right? So the index, the probability index must be 0.9. So that's 90th percentile of 10,000 random numbers from the standard normal distribution. 1.27. Is it close? What do we know? So let's check. It's actually kind of close, right? So this is answer I got from this simulation. Okay, I just simulate a lot of random variables, get an answer, approximate answer. And this is more like exact answer using the solution. So Q norm means quantile or percentile of normal random variable. So the exact answer was this. So anyway, that's how you find out some answers of some problems. Now you can change the mean and standard deviation of the normal random variable. The default is 0 and 1, but it doesn't have to be. So mean can be 10 and standard deviation can be 0.1. Okay? Then you can generate random numbers from different normal distributions. You can actually generate random numbers from any normal distributions by changing the mean and the standard deviation. Okay? Depending on what you want. So that's a number from a normal distribution. What about other distributions? A bunch of other distributions, right? Like uniform. So we use the same method to make up this word. R means generate a random number from a uniform distribution. And I want just one number, okay? I want a lot. Now, the default is between 0 and 1. You can change it, okay? So let's just do 10. So are you typing them? Are you doing it? Type every comment that I do over here. You can change the minimum and you can change the max. Now suppose that you have this uniform random variable between -1 and 2. Do you know the mean of the random variable? Do you know it? Uniform between -1 and 2. What's the mean? 0.5, right? It's kind of easy, the center point. Now, let me give you something a little bit harder. What's the standard deviation of that uniform random variable? So it's a lot harder, right? So traditionally, you have to take this integral and find out the variance and take the square root, right? But the thing is that if you can generate a lot of random variables, you don't have to get an approximate answer. Now try to find the answer. Apply whatever you saw before and find out the standard deviation, approximate answer for the standard deviation of the uniform random variable between -1 and 2. Okay? So write down your code. Did you get something like 0.8? Okay. So 0.86 something. To make your answer closer to the true one, the true answer, just increase the number of simulated draws. Oh, one thing I forgot to tell you. You don't have to retype everything. Do you know that you can use this key? This up arrow. You see up arrow and down arrow. And you can get the comment you typed before. So if I type it, press it once, I get it. Press it twice, 3 times. Okay? So you don't have to retype everything. Okay. What if you like to know more about this R uniform function? Okay? The name of the function you need is help. And then you start to read it, okay? So that's how you learn. Now the next topic is the assignment. So please type this, x, the lowercase x, and then make an arrow. And press enter. So what is your x? What is your x? 3. So what just happened? This is what happened. So in this line, you create a variable, x. At this moment, it has nothing, no information. Now what you did over here is you assign 3 to x. So after this line, x gets 3. That's the assignment. Okay? So type this. So y gets minus 5. So again, you create another variable y, and you assign minus 5 to y. So if you press enter, y gets minus 5. Y is minus 5. So my x is 3, my y is minus 5. So what happens if I say x plus y? It's going to be minus 2, right? X minus y. 8. X times y. X divided by y. So this is the assignment. You create a variable, assign a number. Can you change it? Of course you can. So if you assign 11, what is x? It's not 3 anymore. It's 11 because you assign a new number. So x times y will be different, right? So this is one way to assign a number to a variable. Another way, so this is very confusing. So this is the another way, an identical way to assign a number. So we use an equal sign. So one equal sign means gets or assigned. X gets 4. So this is an assignment. So after this line, x is 4. Y gets 2.5. So y is 2.5. So you can do this operation. So there are two ways, okay? An arrow and one equal sign. Okay? So what is the true equal sign, actual equal sign? You have to use equal sign twice. So this is the meaning of is x equal to 2? Okay? So one equal sign and two equal signs are very different things. Is x equal to 2? Is it true? It is not, okay? It does something very different, right? If you say x gets 2, then of course x is 2. Is x equal to 2? This time it is true, okay? So again, don't be confused. One equality means assignment. Two equality means actual equality, okay? So in page 3, I have two quizzes. So try it. Quiz 1 and quiz 2. So what it says is basically this. You define function y as a function of x. It's x plus x squared plus sine of x. So I want you to evaluate this function when x is equal to 2. Okay? So try this. So what's the value of y when x happens to be 2? So what's the answer for the second quiz? 1.3. I think, I'm not sure. It looks like this 1.3. Okay, so that's an assignment. So you just assign a number, right? So you just created a number, a scalar. But the thing is that when you analyze data, one variable is usually a list of numbers, a vector. Okay, so you have 100 numbers, like heights of people at some place, okay? Or 50 numbers, GPA of students in this class, things like that. So useful thing in the data analysis is a vector, a list of numbers. The thing is that how to assign a vector to a variable. Now this is how you do it. So we are going to use function c. So what it does, can you type it? So it connects everything in it. C means connect. So you connect three numbers, 1 to 3, make a vector. Okay? Make a longer vector. So that's how you make a vector. And then you can assign it. So x gets. So do you see these numbers? In the lecture note, can you type them? X and Y? So we assign a vector to x, a different vector to y. Okay? So once you have two vectors, it's like you have two variables, and you can do a lot of things. It's great fun. So if I say C, parenthesis, x comma y, what does it do? Can you guess? Again, it connects everything in it. If I say plot x comma y, what does it do? Make a plot, okay? So x, the first argument is on the x-axis, horizontal axis. Second argument goes to the vertical axis. So this is how you make a plot. When you have two variables, you can make a nice plot. Now you can do more. If I say sum of x, what does it do? So it basically sum them up, everything in there. Length of x, 7, so you have 7 numbers in x. So if I take sum and divide by length, can you tell me what it is? That's the mean, the sample mean of x. So you can get the sample mean of y too, or you can use this function, mean of x. Variance of x. Please type them. So what's the standard deviation? There are two methods. So one is to use a function for standard deviation. Do you remember the name of the function? SD. Or you take the variance and you take the square root. Okay? So that's another way. Minimum of x, max of x. If you sort x, what does it do? It reorder everything x in an increasing order. Now let me give you a quiz. Can you sort the same numbers in a decreasing order? How do you do it? Try. Sort x in a decreasing order. So the numbers are increasing, right? But if you want to make it to decreasing, how do you do it? How do you find the answer? You basically like to know how to use this sort function in a slightly different way, right? So we need additional information, right? decreasing이 false니까 이거 true로 바꿔봐요. So how do you find out additional information about this function? Okay. So the default is sort of some vector, a list of numbers. Default is decreasing is false. So it's kind of a very convoluted way. It means that it's going to sort numbers in increasing order. So what you have to do is to change this option. So you have to turn it on. Decreasing must be true, not false. Okay, try. So when you're not sure about what to do, use the help. So x is a 7 by 1 vector, y is a 7 by 1 vector. So can you add two vectors? Can you do it? The term by term addition. Can you multiply two vectors? Yes, term by term. You can divide it. Now the question is this. X is a 7 by 1 vector, but mean of x is a scalar, 1 by 1 vector. Okay? So can you subtract the mean of x, 1 by 1 vector, from x itself? The thing is the dimension is not matching. It has different dimension. So the thing is that this doesn't make any sense because it's not well defined. 7 by 1, 1 by 1, so we are not supposed to do it. The thing is, R is smart enough, so it understands we can make a mistake. It fixes the problem. Okay? Just matches the dimension. So what I want to say is this actually. R sometimes overdo it. Try to make too many guesses. So you cannot just take everything for granted. You type this and that, just make guesses here and there, and it worked. You produce a number, right? Does it mean that you just get a correct answer? There is some uncertainty. So sometimes you can make a mistake here and there, and R fixes it in its own way, but there's no guarantee that that's what you actually meant originally, right? So you have to check it many times. That's what I want to say. So right now, your code is very simple. So there's a little room to make a mistake. But once you get more comfortable, do more things, and the rooms to make a mistake becomes larger and larger. So check it many times. There's an exercise in page number 4. It's a weight and height. So we take the measurement of weight and height for 5 people in our class. The weight is, I think that the weight is in kilogram and height is in meter. Okay? So how do you analyze this information? How do you analyze this data, this sample? So this is how you do it. So please type them, everything in there, and get some feeling. So how you actually get the data, and once you get the data, 2 variables, and how you enter this into your computer in R and start to analyze. Okay? Define something else like BMI as a function of weight and height, and make a plot, and calculate mean and variance and covariance, things like that. So please type them. Okay, so we defined weight and height, and then you can figure out the mean, standard deviations, things like that. Oh, by the way, the variance of weight can be calculated this way. How about covariance of weight and height can be done this way. Correlation coefficient. Oh, there's no function called CORR, so I must made a mistake. So I'd like to talk about the plot. In a function plot, the first argument goes to the x-axis, the horizontal axis. Okay? And the second argument goes to the vertical axis, y-axis. So this make a plot like this, right? Height and weight. If you change the order, you have a different plot. So weight and height. It's different, right? So you can determine which variable go to the x-axis and which variable go to the y-axis. So height is my x-axis. So I just make a plot of weight as a function of height. And of course, you can change it. What about BMI? So this is a function of BMI. This is a plot of BMI as a function of height. What if you like to know more about this plot function? And you start to read it, okay? There are a lot of options, maybe too many options here. Let me just mention a few things. So I like to say that this is a function of, this is a plot of BMI as a function of height. So how do you put the title? So it says main gets, so when you enter a character, not a number, okay, so far we only assign a number to a variable, right? But you can enter or assign a character, or many characters, but you need this quotation sign, double quotations. So main gets, the main as a variable gets this. This is a plot of BMI. We have a title, right? There. Now, right now, the label in the x-axis and y-axis are kind of clear. So sometimes, what if it is not that clear? Then you can say x label gets, again, this is characters, right? So we need double quotations. So x lab as a variable gets height. And y label as a variable gets. And we have a plot which is a little bit nicer because it has the name of the variables in both axes. There's a lot of other functions and options in it. So if you say PCH gets 2, what does it do? So one dot means one observation, one person, right? Height and the BMI of the same person. We used to use a circle for that person. Now we use something else, right? Triangle. What if PCH is equal to 3? And you use different things. So this depends on how you want to make your plot. What else we want to use? So PCH and maybe type. So type gets O means what is, I actually forgot about these options. So type gets these as an input. P means point, N means line, B means both. So you have points and lines. O means both overplotted, so line and points at the same time, which is not such a great choice. This example. So read this help page and teach yourself, okay? So let's make it very simple. I have a plot of BMI, and suppose that I like to make a line, okay, that go through these points. So how to make a line? There are a few functions. One easy function is use this. AB line means a straight line, okay? A means an intercept of the line, and B means a slope, okay? So the intercept looks like a good intercept should be 27, slope minus 10. Oh, where did it go? Okay, let me retry it. So you have to make a plot first, and then you can add other things, okay? So plot function must come first, and then you can add, for example, an AB line. Oh, I see. So 27 as an intercept was not such a great choice because this is not 0, right? So what kind of plot I want? So let me retry it. Height, weight. So let me make a simple plot of height and weight. And let me cheat. So in my example, A gets 45, B gets 10. So we have a plot in a straight line inside, okay? Which is not that great. What if I change to 15? So 35. You can change the color though. Blue. Produce this plot. Okay? So there are a lot of options to make a plot. Okay, so let's move on. The next section, create structure data. So what does it mean? This is something like that. Suppose that you like to do some analysis and some part of the variable coming from like survey or something like that, but some part of the variable is just purely numbers that you have to enter. What I mean is, suppose that you have 100 people in your survey, right? And you like to give them number from 1 to 100. So how do you do that? So the straightforward way is define a variable like number. So let's just say that num is a variable. Get 1, 2, 3, 4, 5. So you just enter the whole sequence of numbers. So I just enter from 1 to 10, which is already a lot of work. So what if I have to enter more? 1 to 100, 1 to 1,000. or 1 to 1 million. It's a lot of work, right? We don't want to do that. We like to have a better way, a convenient way. And there are a few tricks to use. So for this ordered sequence of number, one thing we can use is a column. Okay, type it, please. Let's see what you get. So instead of saying num gets C and type it, you simply say num gets 1 to 15. So it saves time. So everything increased by 1, right? What if the other way? You want to make it decrease by 1. From 20 to 1. How do you do that? Now in this column, although it's very simple, everything must increase or decrease by 1, which is a constraint, right? But if you want to make it increase by 2 or 3, how do you do that? So the second trick is to use this function, sequence. Sequence gets 2 arguments, the first number and the last number, okay? Default is everything goes up by 1. Or everything decreased by 1. But unlike the column, sequence has more option. So you need a number increased by 2. It says comma by is equal to 2. So suppose that you have to create all the odd numbers from 1 to 5,000. How do you do it? Okay? Now increase by 3. Something like that. So there are more. But because of time constraint, let me show you other tricks a little bit later. Now the another thing I like to show you is repeat. So it takes 2 arguments. One number you want to repeat. I like to repeat 1 10 times. Type it. What if I like to repeat this sequence 5 times? Then you said you can mix them. You take this sequence and repeat it 5 times. Now, if you want to change it slightly, sometimes in your data it is convenient not to repeat the whole thing 5 times continuously, but repeat this number 5 times, and then this number, and that. So how do you do that? Find it out. So again, you need more information about this function, right? So how do you find that additional information? So one option I like to try is this times, okay? Let's read it. Integer vector, given the number of times, repeat each element. So let me try this. Hope it works. Oh no. So it's a wrong options. So, oh, there's something else. Look at this, each. Again, that's how you teach yourself. So, times option didn't work. Let's try this each option. Oh, it works, okay? So that's how you repeat the same number many times. Okay, so let me stop it. So our next class is tomorrow, right? So we have class in two days. So tomorrow I'm going to finish this note, and then we are going to move to the next one, which is a review of statistics, probability and statistics. For this review, I don't plan to spend a lot of time. So please, there is a reading guide, and there is always a lecture slide. I just try to explain some basic idea. So please read them before you come. And remember that your first assignment is due by tomorrow. Okay, I'll see you.